Isn't this cool? A line follower robot that can follow the black line on the white surface. So I am thinking about to do something better than line follower robot. So here is my project, the advanced line follower robot, which have added some functions. So let's check it. Welcome to my channel VFix Technology. This is Subhashish Bhanna. Today I am going to present a advanced line control line follower robot with some advanced features. So its features. This is the line follower robot. You can see there are some components are added as you can see in the picture, and there is one funnel, one servo motor, and some apertures are fixed on line follower robot. So when you put some weight on the carrying funnel, it will start moving towards the unloading station. As soon as it reaches the unloading station, the robot will stop, and then it's open the funnel valve. The funnel valve is installed here. I am let you know details in future, and started unloading. Once the unloading is completed, it motor again start and going towards the journey loading station. On loading station, when it reaches to the loading station, it will again stop and wait for the load is being carried. So on loading station, once the loading is completed, it will start again and it goes towards the unloading station. So this is the basic of the project. So what are the component is used? The component is used basically it's a Arduino based project. So Arduino Uno I have used, and as you can see in picture, this is the front view of the robot, where you can see the two IR microcontroller IR module is fixed here to check whether the black line is inside it or not. To the Arduino Uno is here. Here is the servo motor fixed, and this is the valve. This is the side view of the project. You can see the DC motor right one, and the Arduino board is here. This one is the MFRC RFID tag, which detect the loading and unloading station. So there is two cards presented at loading station as well as unloading station. So from both this card, as you know, the RFID has unique RFID tag. So based on their RFID tag, it can detect whether it is on loading station or in unloading station. This is the L298 motor. This basically drives the two DC motors fixed on it. You can closely look that the 6 pins, the connectors are going to interface with the Arduino Uno to control the L298 module. This is the load cell. Load cell is fixed to check whether the weight, what are the carrying weight currently with the robot. And this is the servo motor, micro servo motor. This is basically opens or shuts the valve just bottom of the funnel. And this is the load cell amplifier board, you can say HX711 board, which is basically a AD converter which convert the analog signal to digital format and sends to the Arduino. This is the carrying funnel, and you can look closely on the HX711. And behind this there is one jumper board. This is basically power board. It's supplying all the 5 volts and the ground to several the components. This is the bottom view of the robot. This is the RFID tag you can see, and these two are the infrared module, and the caster wheel is acts as a center point of the module. This is the track which is used for driving the road, and this track is made with paper and black color lines with paint. As you can see, there are two stations. This one is the loading station, this is unloading station, and this one is the loading station. The both that station, this is a RFID tag is there to detect whether it is on loading station or not, and this one is RFID tag is presented here to check whether it is on unloading station. So let's go through quickly about the basic components. The components required to make the project is Arduino Uno, L298 motor driver, DC motor with wheel, caster wheel, IR sensor module, load cell and H7X module, servo motor for unloading valve, RFID module, RFID tags and jumper wires. Now let's go through the coding part of the program. It's begin program with the Arduino IDE. So I have included the servo library, as there is a servo motor, included the HX711 module for the load cell library. These two are, and I have included the SPI interface and the MFRC522 RFID module. I have defined the load cell out, D out and clock pin as 2 or 3, and motor RPM pin is there 5 or 6, and there are 4 motor enable pins are defined as 4, 6, 7, A4 and A8. I have defined the position. The position is for the loading station, whether it is on loading station, whether it is on unloading station, or whether it is on track. MFRC layout is as given below. So in setup, I have started the serial for debugging purpose. You can stop the serial begin for later on when the project is ready. Servo need to be defined. Servo pin is attached. The scale begins. Scale means the load cell is begin to starting, and the pin mode is defined as output for the L298 drivers, and these are as a input pin. Now MFRC is initializing, and it will start printing about the data box. So there is function is called, I have created a function check wait. It will show you the analog value of the digital value of your scale, and there is motor handler. As I have used the 4-pin IR sensor module, it is directly having the D out as well as analog out. If you are going with the analog out only IR sensor, you can convert it to a digital ones, or you can put read the analog as a threshold value and set the threshold value as analog value. So whenever both sensors are giving the active low, that means all are in track, and the motor starts RPM is defined as 80. I am set the motor's speed is quite slow to show the demonstration project is easily. As you can vary the speed as based on your requirement. So motor enable is basically moving the motor forward, and motor revision is reverse is the moving the motor backward. So as both are in track, this time motor will go forward. Motor 1 and 2 both are in RPM 80, and both will turn on the forward direction. If left sensor is on giving the data 1 and right sensor is giving the data 0, that means the left sensor is on black track and right sensor is on white track. So you need to move the motor on right. So by turning the motor right, whatever I have done, that I have set it that RPM is different. For motor 1 is RPM 70 and motor 2 RPM is 120. Motor 1 is enable low, as motor 1 will motor forward is low, motor enable 2 is high. That means right motor will turning on 120 RPM and left motor is reverse. Left motor is starting reverse at 70 RPM. So it's quickly turning to right. As well as for left moving, there was motor RPM which is defined as different condition 120 and 70. So right one is starting on 120 and left one is reversing on 70. And if both motors are on black line, that means it will stop. It's actually not required for our project, but I have done for the demonstration purpose and for debugging case. If something found in track, we need to stop somewhere on an emergency, we can put a black label over there and the motor will stop. So this is the motor handler function. There is one function is RFID check. RFID check, for checking the RFID is need to be reset first and then it will be initializing, and it will check whether new card is present. If there is nothing present, that means the card is not in the any of the station, that means position is 0. And if there is no card is serial is present or there is no new card, both cases can only happen when this bot is not detecting any of RFID tag. If RFID tag is represent, it serial print the RFID tag. And what is that? It serial print the RFID tag, then it will I have defined the string content and byte the letter, and the byte is as there is 4 byte of ID, 4 byte of UID size is the 4 byte. So it will read the UID byte and concatenate it into a string. So then it will print the device tag into your serial monitor. If now we have the predefined card for starting station, loading station and unloading station. The loading station RFID is put here. If you want to change as per your, you need to change as per your UID card data. And this is the for unloading station, and both cases it will print the authorized access, and position is detected at 1 and position detected as 2. So for unloading position is 2 and for loading position is 1, and if the bot is on track, it will show the position is 0. Now this is the loop, where for loop it will first check the RFID whether it is on position 0, 1 or 2, and it will say serial printing the position, and after that it will call the function check weight will check and print the current weight. Now if position is 0, based on this result, if position is 0, that means the bot is on the track, and it will directly call the motor handler. Motor handler will work as per his routine, and it's also serveride the 0, that means the valve will close. So when the motor bot is on track, so it will always close the servo motor, so that the loaded material should not be unloaded. Now if position is 1, that means the bot is came to loading station. So loading station I have defined as per my load cell value the 85,000, that means sum of the weight, when until the weight reach to 85,000, it will stop the bot as check weight, and it will print the reading, and PWM will 0, motor enable will be 0. So stop all the motors until the weight is getting on predefined limit. when they exceeded the predefined limit, it will again started the bot. And when it is on position 2 as well as it is on unloading station, it will wait, it will check whether it is below the limit or not. Whenever it is below the limit, it will start the servo right valve is open as 180 degree. As soon as the servo right is opened, the truck is getting unloaded automatically if we put some fuel or over there or some liquid value based on your project. Actually, as I have worked with a funnel, it will work on the liquid, and if we work on the solid, we need to fix a big funnel or big valve over there. So that's it for the programming. So now let's upload it to the Arduino and test it. Let's upload the program. This is the bot and I am pressing the upload screen. It's compiling. Uploading is completed. So it's now to soft test. It's now time to soft test the product, soft test the code. I have put a black seat behind just bottom of the robot so that it can't move anymore. So I am opening the serial monitor now. As I am stopping the auto scroll to check from behind, the firmware is showing, and this is the position is showing, position is 0, and the initial reading for the load cell. So I am again starting auto scroll and I am putting some weight, as I don't want to mess in my house, so I am not using any liquid. So I am this paint box I am using as a load for future demo purpose. So just putting the load, and you can see the reading is changed to 70,000. Initially it was on 65,000. That's I am again removing the load. So load cell is working fine. Now position is 0, as there is no RFID tag is presented in the board. So here I'm going to check the RFID tag is working or not. So I am placing the RFID tag behind the robot and it will see the, just I am stopping auto scroll. The position is 1. So whenever it detects the position 1, it will again work as per our program. And this is the RFID tag I am placing here. You can see the RFID position is showing on the serial monitor. So the now project is ready to rock. Let's have a look. So now I am checking with the RFID part of the unloading station, and I have put the bot power on and place a black plate over there so that bot can't move anymore. If I remove the black plate, the bot will start moving. So I am placing the bot now. As it is an unloading station, and on unloading station the valve is, as you can see, valve is closed. That means the valve position is in here, it is closed position. So now I am putting some weight, as you practically will place some liquid or something else, so that as I don't want to mess in my house, so I am putting a solid load. And now I am placing the RFID card. This is the station RFID, unloading station RFID. I am placing the RFID. Please just see this section, this one. This is the valve, shut valve to unlock the funnel. Now I am placing the card. As you can see, the shut valve is opened, and I am just, what I am doing, I am just removing those weight, so that check the shut valve should come on its original place. So I am removing these weights. As you can see, the shut valve is on its original place. So if we place the liquid weight, it will automatically close the shut valve. But in demo purpose, I will place the physical solid weight, and I need to remove it manually. Just check the shut valve function is working or not, or the demo. That's it. And if it is placing the if we are placing the liquid weight, it will close automatically. Now the bot is on track and there is no load. It goes to the loading station. As I don't want to any mess in my house, I am putting manual load. The load is putted and it started moving towards the unloading station. It's reached towards the unloading station, and as you can see, the valve is opened, and I am removed the weight from the weight funnel, and again it is started moving towards the source station, and it stops as soon as reached to the source station. Again I am putting one weight, and it started again and going towards the unloading station. On reaching unloading station, it will stop and open the valve. Again I am removing the weight. Hope it is clear to you. Thank you.